Hi there, welcome back. We're doing the next two problems on the worksheet on graphing gradient functions given given the gradient function. So this one here is a gradient function. We want the actual function itself. You notice it's got no numbers on any of these axes, and that's because when we differentiate something we lose some information, so therefore it's a bit meaningless down here because we don't really know where this function goes. We're only really looking at the position of it, or the shape of it, rather than the position. So at this point here we have a zero, because it's crossed right here, we have a zero gradient. A zero gradient means that you must have either a minimum or a maximum, and you're going from a negative gradient to a positive gradient because we're looking across here. We're not looking at the shape of it anymore. We've got the gradient, we're looking across here at the values. The values along here are negative and the values along here are positive. Therefore we are going from going negative to positive whenever you're going downhill. So that means negative downhill, and at that point there you've got to be at a minimum, and then you're going uphill. This one here is a cubic, but it is a perfect cubic. That's why you don't have the two humps. This one here is actually going to be a power of 4 because there's no smaller terms. You just get what looks like a parabola, but it's actually a power of 4 graph. Right, we're now over onto this one here. We have got obviously turning points at these 4 places here, and then when we have a maximum, this is the maximum negative that we're going to have, that will be a point of inflection, and a maximum positive that we're going to have, that's another point of inflection. So therefore your 0 points are what you're going to have are your maximum min points, and when you've got a turning point on a gradient function, that actually gets you a point of inflection. So let's see what this looks like. So these here are our turning points. I'm going from a positive to a negative, which means I'm going from a positive gradient to a negative gradient, which means I have to turn like this, positive gradient down to negative gradient. Then I'm getting a point of inflection, which is at this point here, coming down. So that means I've got negative, that's my maximum negative, then it's starting to become less negative. Then at this point here, I'm going from a negative to a positive gradient. So from that point there, I'm going from a negative to a positive gradient. So I must be having a turning point. Remember, you have maximums or maximum minimums or turning points at 0. This again is a positive, as a point of inflection, which means that there is where I am turning, point of inflection, which means I'm changing from concave up to concave down. Then again at this point here, I must have a turning point, and then from this point here it's just negative from then on. So that's an arrow, and that's an arrow. So as you can see, we have got 3 humps from 2 humps. If you've actually got a cubic, you are going to get from your gradient function, you will get a quartic from your actual function. Right, let's look at another couple. Right, these ones got lots of information in them. Right, so we've got a point here, we have got a point here, a point there, and a point there. So we're going to have 1, 2, 3, 4 turning points, and we're going to have 1, 2, 3 points of inflection. So we've got a turning point here where it's going to go from a positive gradient to a negative gradient. So we're going to have a turning point, positive gradient to a negative gradient. There we've got a point of inflection. Then here we're going from a negative to a positive gradient. So that's from a negative gradient to a positive gradient. So that means we must have a turning point here. That point there, of course, is my point of inflection where it changes from one to the other. Right. Again, I've got another point of inflection, so it's going to be coming up, and at that point it's going to start turning. At this point here, I'm going from a positive gradient to a negative, and it's 0 at that point there, so I must have a turning point right there. This again is a point of inflection, so I must be, when I'm going from another one, from concave down to concave up. At that point here, again, I've got another 0, so which means I must have another turning point at that point, and then it just keeps on going very highly positive, and this one here goes very highly negative. So I've got 1, 2, 3 turning points. This now I've got 1, 2, 3, 4 turning points. This one here is a power of 4 graph. This one here would be a power of 5 graph. Right, coming over to this one here, again I've got turning points 1, 2, 3, 4 turning points, and I'm going to have 1, 2, 3 points of inflection. Going from a negative to a positive, going from a negative gradient to a positive gradient means that I'm going to have a turning point that will look something like this. That's my point of inflection, and then I'm going from a positive to a negative, so that means I must have another turning point there. Then I've got a point of inflection here. I must have another turning point there where I'm going from a negative gradient to a positive. So there is my point of inflection, and that's my negative gradient to a positive there, so I must have a minimum there. And then again I'm going from a positive to a negative, which means I've got my point of inflection part way through, and it will look like that. Again, this is a power 4 graph, this will be a power 5 graph. I've got 1, 2, 3, 4 turning points. This one has 1, 2, 3 turning points. Okay, well that's about it for drawing functions from gradient functions. Thank you.